So in this video we're going to look at the De Young Museum facade patterning by Herzog and Meuron. Well-known project, sure you've seen images of this before. We're going to go over a method that you can use to produce an effect that's very similar to this, using a very similar process that the firm employed to develop this punch pattern in the copper sheets. And another couple, views of that will show how it goes from nothing to very small holes to slightly larger holes and so on. And one of the things is, first of all, what determines this pattern, what determines the logic, and in the case of this building, an image, a base image determined how the pattern would look. In our case, we're going to pull up an image and use something like this. I mean, they used also a kind of I think an image of tree canopies that were on the site, trees that were on the site, an image of that, photograph of that, and how the light passes through the leaves, and you get these different areas of dark and light areas. Now we're going to start with an image like this, but we're going to convert it into something that will be a little bit more easily abstracted. So something like this. And so what I did is I just took the original image, this one here, and I put this in through Photoshop. I just simply made it black and white, and then I just ran a Gaussian blur over the top of it with a radius diameter of around 30 pixels, and I came up with something like this. After that, I tweaked it a bit using levels to really kind of punch some of the bright areas versus the darker areas. Okay, so we're going to use this as a base image to develop our pattern, and I'll show you a way to do that. So let's launch into it. The first thing is I'm going to be in my front view. Okay, so I'm in my front view because I want this thing to be vertical. And then before I get into the grasshopper stuff, I'm just going to kind of minimize that for a minute. And I'm going to first drop in a base surface, and on that surface we're going to imprint the image. We're going to use that as a reference. As we develop the pattern, we can kind of turn that on and off, so we can kind of see how, if the dot pattern is actually kind of following the image itself. So I'm gonna use the picture frame tool. Okay, so type in picture frame in Rhino, and it's gonna ask you for the image that you want to pop in here. On my desktop, I already have the leaf canopy edit 1, black and white, ready. You'll have this from the UV box downloaded, and I'll open that. And what I'm going to do now is just, you can keep all of this stuff okay up here. You don't have to click anything, but I'm just going to click in the bottom corner over there on the left and just kind of hold my shift key and drag out a window size that's something like this. And that's a pretty good size, and I'll just click. If you hold the shift key, it'll keep its aspect ratio of the image intact. Okay. So now we have an image that's kind of been set into Rhino as a surface. So if I go into a different view here, you can see that. And I can do things to this surface as I would normally do to surfaces. Trim them, scale them, cut them, do whatever. And I'll talk about why we did that in a minute, other than just being a reference, as we get into the GH stuff. Okay, so what we're going to do now is, oops, sorry. Let's put that back into some kind of, yeah, that's better. Okay, so what we're going to do is kind of drop this image into GH. We're going to subdivide it, find those center points, and we're going to use those center points as a way to develop, as basically locations for the holes. So the first thing is, the drill, I think here is to drop this surface. Let me turn the icons off. Drop the surface parameter in so that we can set that in from Rhino. So right click, set one surface, and you'll see that that goes green. And we'll leave that, again, we're going to leave that image on for a second while we continue to work here. The thing I'm going to do next is I'm going to make sure before I forget later, is reparameterize that surface. So I'm going to right click and just click on reparameterize here. And we'll see why that's important later. And similar to the first workshop we did, we're going to break the surface down into separate panels. So I'm going to go to Surface, Utilities, Isotrim. Okay. And I'm going to drop that in like so, and I'm going to go over to Math, Domain, all the way to the bottom, divide domain squared, and do something like this. Okay. And I'm going to turn that old preview off because now I have overlapping previews, so I'll turn the first one off. And you can see now that I've got a series of rectangles, surfaces that have been kind of redrawn through the original. And we need to add some density to this to kind of develop our hole pattern. Okay, so that's going to be set by our U and V values. So I'm going to go over to parameters, grab a panel, and I'm going to kind of just pop in 120 for the first value and put that into U. And copy and paste that out and just drop in something like 70. We'll see if that works. For the second one, for the V. Yeah, and your computer's going to slow down a bit, and that's pretty normal. I mean, we've just done a lot of work to it. And so we have a lot of surfaces now being defined. So it'll be 120 by 70, so that means we get, in this case, 8,400 surfaces being drawn as separate surfaces. And we could turn this off because we really don't need to see that. At this point, what we really want is just the centers. There's a lot of different ways to develop a grid of points like this. I mean, we could also have just drawn a grid. We could also have divided the surface into points. But the issue is that you'll end up with points along the edges. And what I wanted to do is make sure everything was inset. The pattern was always inset to the image as a way to reference it out properly. Because otherwise I get things that are kind of hanging off, right? My whole pattern would end up hanging off the edge. All right, so to find that set of holes, we're going to just find the center point. So I'm going to go to surface, area, right? And that's that little area button there. And you know, right away, your computer might take a minute here, but yeah, we're drawing a center point now for each one of those surfaces, right? And we're going to use this as, this is going to set our density for our whole pattern, which I would say is good because obviously we've got a really kind of varied image in the background here, going from light to dark areas, and we want to be able to capture a lot of that in order to mimic it in a way, or to kind of use it as a real reference. So we can kind of see a version of that image starting to emerge through the holes themselves. So we really do need a high resolution. Okay. Now again, if you didn't draw your surface out this large, and I'm in inches here, we should pay attention to that a little bit. I'm in inches. I drew my surface out almost the size of the, you know, this quadrant of our coordinate system, and I'm almost all the way. You can make it a little bit bigger, and that would be good. I probably should have gone a little bit larger, but this should work fine. If you drew a really small surface and you input the numbers over here, you may end up with something that's way too dense. You'll know that later when we start playing with the circle pattern. The last thing is we need data that we can work with, because we're going to run these points through what's called an image mapper. And we're going to need that image mapper to actually develop a set of, I guess, numerical values for us that we can use to set the diameters of our circles. So one way to do that is to force these points now to coincide with those surfaces in order to give us more data. And we're going to go to Surface Analysis, Surface Closest Point. Okay, so we're going to use that one again. We've used this one before, and we're going to do this. So the point itself goes into the P input, and the surface, of course, goes into the S input. We're going to turn off the preview for the area component and just have a look at what's coming out on this end. It's going to look exactly the same, except now we have an output that's UVP. All right, this is going to be a good output that we can use that's different from just the X, Y, and Z coordinates in that it's now being described between 0 and 1, and it's a good set of values that are basically going to now be used as a base from which we can develop a new set of information more relative to the image itself. So the darker areas will be a smaller or larger, and the inverse proportion will be the lighter areas. Okay. All right, so let's see what that looks like. Let's go over to parameters, and the input tab will have this here, image sampler. So it's the one with the green icon. And by default, it's going to look like this, okay? Because it's looking for an image. So what we can do is set some data into it. So we can right-click and go to Settings. And here's where we can set an image, a file path, essentially, to this component. So right now, my image is on the desktop, so I'm going to just click this little button here. Select that image, leaf canopy, edit 1, and pop that in. And as you can see now, our image is being described between 0 and 1, 0 and 1. So anything along this, any kind of data coming out will be will be described between 0 and 1, which is good because we reparameterized our surface. If we had not done that, we'd have to update these x and y domains relative to the pixel size or dimensions of that surface, but it's a little harder to get that right, so it's a bit faster to do it this way. Okay, so to keep going, I'm going to, and then we want to set a channel. So this will determine what comes out, right? So this is going to determine how this image is being read. And because we have a black and white image, it makes the most sense to use this one all the way to the right here, which is this color brightness channel. So we're really going to be measuring the brightness, the dark to light areas, and outputting a set of values relative to that, proportional to that. So again, the darker being a value of, let's say, all the way up to 1, and a lighter being a value all the way down to 0, potentially. Okay. And I'm just going to hit OK. So what we see now is a representation of that image in our window here, and you can rescale that if you think it needs to be a little bit more accurate to the aspect ratio. It doesn't really matter. The size of the component won't affect anything. And now what we can do is just go ahead and plug our UVPs in to this component. And let's have a look at what we're getting out. All right, so I'm going to use a couple panels just to kind of see what we're getting. And yeah, you can see now we've got a bunch of values relative to those points. So a point comes in and has a location along that image. That location is being read relative to the bitmap image that's behind it. So if that point overlaps a dark or light area, you'll get a number that coincides with that. Okay. So this is going to be the start at how we're going to start to develop, some kind of a whole pattern based on this. Now, what I'm going to do now for a little while here is to just kind of hide. I'm going to go to Rhino. I'm going to select that surface and hide it. I can always bring it back later by typing in show. But for now, I kind of want to do a little GH work just on my data here so I could get a start on the next set of steps. Let's draw some circles, okay? And we're going to go a little bit beyond this after this step, but let's see what we get, just out of this pattern right off from the onset before we start going a little bit too deep. So what I'm going to do is I'm going to go to curve, grab the primitive circle component, and I need to put the proper plane in here relative to these points, right? And we are in the XZ plane because we're in the front view. Okay, so I'm going to go to vector, grab my XZ plane over in the plane tab there, right? And all the points are still going to be these points. These are all still valid points. So I'm just going to move that thing up here like that. I'm going to turn off that component because it's going to get a little loud. And drop that into my... Now you're going to get a lot of stuff going on because obviously those circles are drawn too large relative to the spacing because the radius has not been set to that yet. So we're going to use this data coming out of the graph mapper to see, or the image mapper to see what happens. And we're going to start seeing something emerging here. The circles are still too big, as you can see. Okay, that's not a problem. We're going to kind of manipulate this data to make this work, but you can see that it's already starting to work out a little bit. And if I type in show in Rhino, you'll get a sense for that, right? In this case, actually, is the opposite of what I said before. So the darker the area, the smaller the circle. Of course, we can invert that if we'd like. I'll show you that in a second. The first things first to try to get this thing to work. So we're prototyping it at the moment in order to see, at least that our pattern is kind of reacting right. So simply, all we got to do is kind of divide this. So we're going to go to math, divide, take all these values out of here, and just divide them by kind of a generic number, and for that I'll just use a slider. I'm going to double click and just use a slider between I guess 0 and 10, so I'll just type in 10. Actually I'll type in 5, and that should bring me between 0 and 10, and then I'll right click on that actually because I want this to be a slider type of floating points. I want to be a little bit more careful with how I'm dividing this, and just do something like this. Okay, so we're going to divide those numbers to make them smaller so that I can actually kind of see this thing working a little bit better. And as I increase this value, your circles will become smaller and smaller. Now to really see the whole pattern, you can zoom in, or we can just kind of, it'd be helpful also to turn off the center points so we can compare our whole pattern to the background image relative to the way that we scaled these circles. Okay. And it looks like it's working out very nicely, right? So we have a direct relationship between the image and the whole pattern. Now, if we wanted, we could be more or less, this could be something that we can consider to be done. We're not done yet, so don't click off. There's a lot more I'd like to do. But if we wanted to invert this, that's one thing we can try. Okay, so if we wanted to invert this relationship, what we need to do is take these values and invert them. Okay. Because they're all between 0 and 1, that's probably just a matter of subtracting all of these from 1 to get a new set. We can give that a shot. The other way to do it is to go to math and kind of remap our numbers. Okay, so we're going to grab the remap component and we're going to give this a shot here. So these are our original values, right? Our source domain is between 0 and 1. We know that to be true, and we just need to give this a target domain. And actually what we can do is just simply reverse that domain to 1 to 0 instead. So I'm going to go back into my math tab over here, grab a construct domain component, pop that in like this, and then I'll use a panel to type in 0, okay, and to type in 1. There's a few different ways we can do this. This is just kind of the most clear. And now what we've done is we've kind of inversed all of that information, right? And we can now plug that into our divide component just to see if it inverts properly, and I think it should. Yeah. So now the darker the area, the larger the circle, lighter the area, the smaller the circle. You know, and again, another way we could have done this because we're between 0 and 1 is to just simply subtract all of these from the value of 1, and that would also invert it. Okay. It's more or less the same thing here, but it's good to know how this remapper works just in case you're working with domains that are not between 0 and 1. That method, of course, wouldn't make any sense. So I guess we can leave it like this. We can always go back and flip it around a little bit later. And so just to see the pattern a little bit better, I'll go back to Rhino, hide that surface. I'm going to kind of minimize grasshopper a little bit and really see this thing, have a look at it. And yeah, I think it's coming out nice. So we've got a good prototype, we've got a good start. The thing that I want to the way to continue this, I think, would be to do a couple things. Now, we know that we have some ability, first of all, to make sure that these circles don't overlap. And that's simple. We can just divide the value, right? So we can make it smaller or larger. And of course, this is a problem for fabrication. You know that would just produce basically a big hole here. Overlap is not going to work. And, you know, we could also be too close depending on the manufacturer's constraints, you know, the material constraints and the machine constraints. So we might want to be a little bit more careful with how we're doing this. The other thing to keep in mind is, you know, for example, if we needed to set an actual distance between this as a minimum, like 1/4 of an inch or something, depending on the machine, we would need to know where we stand there before we kind of sent these drawings off to the fabricator. The other thing is that it's very possible that the majority of these holes are all different sizes. Some of them are probably going to be very close. Some of them are probably repeated, but that's, you know, that's just due to the image. But the majority of them are all are slightly different based on this kind of varied image. Now, if we're using a laser cutter, there's no problem there. You know, you just laser cut it. Theoretically, that's not a problem. If you're using a different kind of machine, which was used on the De Young Museum, we may need to actually be a little more, I guess, we'd have to have more, we would have to be able to break these circles down into a series of diameters that are very specific. And the reason for that is that turret punches, for example, they use sized dies, so predetermined dies. And a die is a little cylinder that basically gets put into the punch, and it punches a hole to the exact diameter of that die. And, you know, of course, they don't have an unlimited number of dies. So let's say they have a set of 8 dies. It's good then to break this whole pattern down into distinct sets that keep its variety more or less intact, but still kind of optimizes these circles to kind of round their diameters up or down slightly so that it fits that die diameter more appropriately, right, or dead on. So this will be a little process that we'll go through to kind of break this pattern down into, let's say, optimize it for fabrication parameters. And one of the things that we're going to do is, first of all, take care of this overlap. Now, you can see that when I'm zoomed into this area, there seems to be no problem. The division works without an issue. Over here, though, you know, I wasn't looking at it, and now suddenly I have this problem. So, you know, the only way to do this is by eye, and I don't think that's good enough. So let's just set a minimum to this, all right? Let's set it so that that will never happen regardless of these values coming out. All right. And one thing we can do is just go to I think it's in the Math tab, yeah. And under Utility, you're going to find the minimum component. Okay. And I'm going to move this over here, and I'm going to kind of slide that right in. And I'm going to set a minimum value, right? What this means is, we can hover over it, it's going to return the lesser of two items. So I'm going to set a value which ends up being its maximum value by always returning the smaller number, right? So if this is a value of, let's say, 1, anything smaller than 1 will come out of this. Anything larger than 1 will be held back. Okay, and that's a good way to kind of help this little component out so that it doesn't actually have any overlap. And to do this kind of carefully, I'm going to make it a little equation that's going to be relative to the actual spacing of our center points. Now, of course, you can put any kind of value in here, and it should, sort of work. But if we really want to make it parametric, we can determine how big these radii need to be and the spacing between them relative to the spacing of our grid itself, which, if we changed, everything would update nicely, right? Okay. So what I'm going to do is just kind of, first of all, isolate. I'm going to go to set. I'm going to grab a list item component, and I'm going to go back over here to my points, and I'm going to pop that in like this. And I'm going to grab that first point. Okay, that's my point 1. Now, depending on the order that this is in, it's either going to go up or down when I zoom in. So I'm going to zoom in, grab the second one in order, and I see now that I've drawn the next one up in space. I can measure between them and get my vertical height, right? I can get my vertical distance between the points. So I'm going to just going to label that. Okay. Now, if I want to get this distance, I need to grab the same component, right? So set list item, and we're going to put the points in there again. And now what I need to do is figure out which of these values to use in order to find the next one over, because this is all numbered, right? So it's going to go 0 through whatever, probably up to either in this case 70, and then it's going to come down again, right, and recount. So it's going to be one of these values that's going to be the index for that next one in line, and I think it's 70. It is. So it's drawn 70 points up, and because of that, I'm selecting the next one in line here. So this is going to be my horizontal distance. Okay. And all we got to do now is just go to vector, distance, and just measure it. And here we can copy and paste that and swap out the B input for that point there. And we've got our two distances, okay? Let's figure out which one is smaller, and we'll use that to set our maximum value, right? Because then we know they won't overlap. All right, so this is going to be our smaller distance, and that makes sense, and that's based on how we subdivided the surface to begin with. All right, so we're going to use that one. And we can always switch this later. We can use this one later if we ended up, again, like, redistributing these points based on a different XY breakdown. But for now, we'll go like this way. And so go over to, so we're going to set a little equation that's going to be based on this number. So we'll go to Math, Evaluate, and grab one of these. And what I'm going to now do is, not only am I going to use that spacing as a way to set the distance, but I'm also going to put a value in there, a Y input, that's going to determine what when that maximum spacing is set, what the offset between the circles is actually going to be. Okay, so I could do that as well. And I'm going to use the panel for that, and I'm just going to type in 0.02, a small value just to test it for now. And that's some fraction of an inch. If we were in different units and we were a little more careful, we can probably be a little more precise, but this will give you the idea. I'm going to grab another panel, and this is going to be my equation. This is pretty simple. So I'm just going to divide the distance, which is x, by 2, right? And I'm going to subtract y from that result. Okay, so x divided by 2 in parentheses minus y. Okay, and that's going to go into F, and it's going to go red for now, no worries. It's just that it doesn't have an X input yet. And the X input is going to be our distance value here. Okay. And we're going to use this number as our maximum radius for the circles. And now I'm going to replace all that. Now nothing really happened here that's too extreme, but if we go back over to the area where we knew we had overlap, you can see now that it's been fixed. And if I change, no matter what I do to this, you know, I can make that smaller, smaller, smaller all the way down, right? You can see when I'm losing it all now, right? But I still don't get any overlap no matter what I do. All right, so even if I'm only dividing it by a very small number and the circles are really want to be large, they're being limited by what we just did, okay? And they're slowing down, and they're kind of, and this distance between them now is going to be the value, this y value, right? So we've got a nice relationship between this division and what we think is going to be a good distancing, no matter what, kind of a minimum distancing between those circles. And if I go in and I increase this, let's see, like something like that, you can see now it's going to put more space in between and force those circles to be smaller. Okay. Okay, so that's step one in optimizing this for fabrication. The next step is going to be, like I said before, we kind of want to now be able to, we want to set these circles into a particular diameter instead of having a range of diameters that are a very small decimal point away from one another, right? If we have a look at this, you know, they're all pretty much different. I mean, these are identical, but what is 0 point, you know, these are all kind of, it's a pretty wide range of values. Again, the vast majority of them are different, and if it were laser cutter, we'd have no issue, but we're going to assume that it's going to be punched, so we want to kind of break these into sets that have a common diameter, which will make it much easier for the machine to be able to swap out the dies and continue the punching process. All right, so we're going to break this domain down, basically. We're going to take the values coming out of here, and we're going to divide them into 8 separate chunks based on their numerical value. So from small to large, but broken down into 8 chunks. Okay, so the first thing is to figure out what our overall range is. So let's go to math, grab this max and min component like this. And this will give us our bounds. Okay, so we know that we've got values between 0.019 all the way up to 1. And we're going to use a handy component here in the math tab again, which is the divide domain tab. And what this is going to do is divide this overall domain into however many chunks we want. Okay, and by default it's giving us 10 segments. Let's just say it's 8 segments. Okay, so I'm going to put in a panel and break it into 8 segments, and then I'm going to just kind of have a look at that stuff coming out there. Yeah. So it broke down our original domain into basically 8 new ones, all kind of subsets of the original. There's our original minimum, there's our original maximum. So it's pretty cool. So that works to get us started. Now the next thing is you know, this stuff coming out is really just division segments of a, so it hasn't really reorganized the data yet. It just kind of segmented it into ranges, but it didn't actually reorganize the numbers yet. It just used the numbers to make ranges. So we're going to need to use those ranges to reorganize the data coming out of here into 8 different chunks, right? Because we need those numerical values. We need these values to actually be reorganized into kind of separate pieces. What we can do in this case is head back over to the math tab, and there's going to be a includes component. And this is going to test whether or not a certain value exists within a domain that you've given it. So our original values are the same. It's going to be coming out of the image mapper, okay, like that. And the D input here is going to be the domain to test it with. Now, we know we have those domains, but we want to separate them into separate lists. So what we need to do is graft that output. So we can hover over D, right-click, hit graft, okay? Because we want each one of these segments to be treated like its own separate list. And if I do that, you're going to see as we hover over, I now have 8400 times 8, which is basically 8 separate lists of true and false values. So a true is going to come out if the number that's coming out of the image mapper fits within the particular domain that's existing within each one of these 8 lists, right? So if a number is somewhere between this value and that value, it'll be a true in list 0. If it's somewhere between this value and that value, it'll be a true in list 5. If it's not within this range, that value will false, and so on and so on, okay? So we're basically taking the data, in a way multiplying it 8 times and testing whether or not those numbers fit within each one of these independently to develop our call pattern. And this is going to be a way for us to reorganize not only our data, but also our points, right? And that's good because we can then do is set our circles to coincide with that breakdown. So I'm going to jump right into that. I'm going to go to the Sets tab, grab the Call Pattern component, and what I want to do now, and we're going to need to move some of this stuff over in a minute, but what I want to do, because I'm going to need these points again, I'm just going to go over to parameters. I'm going to throw these points in the little the point parameter. I'm going to turn that off. And again, I like to do this sometimes when I've got some stuff downstream that I need to put upstream, just so it's easier for me to grab, especially when I'm doing this video because I have a half screen to play with here. So now I can grab those points. And what I'm going to do is I'm going to use that as my list, and I'm going to use these patterns coming out of the I input as my call patterns, okay? And we can turn that preview off for now because all we need to do is hover over to see what we've got. And this is interesting. So what you can see now is there's overall 8,400, which is good because that's the amount of circles we have, but we've now reorganized them into 8 different lists of circles, or of points, I guess in this case, before they become circles. Now we have 105 that fit within the small range. We have 1,862 that fit within somewhere in the middle, and the other range, the largest range, I think, is the 364 circles, right? So that just is telling us one way that we can start to break down and start to separate our circles into different diameters. Okay. Now you could go ahead and grab these. Our points, though, this component here, remember this plane component, we have to update that. The points are now reorganized here. Okay. And yeah, we have a bit of a data issue. So this is where we get into a little bit of trouble when we're putting 8 lists, right? Comparing 8 lists to a single list. We're getting a whole bunch more data out of this, and we got to be careful with that, right? So, but what we're going to do is try to match up, okay, each one of these lists to its own particular diameter. Okay, so we're going to have 8 diameters that we're going to compare to this, and in a second we're going to use this data over again because I think it works nicely. But just to kind of walk again through the die sizes and optimization for fabrication, here's one way you can do that. So we're going to go to our maths, and we're going to grab construct domain, okay? And by default, this is already at 0 and 1. That's good, because that's what we're going to use for now. And go back to the same place and grab the divide domain component once again that we used before. And here you've got the panel for 8, so you can just copy that, because we want to divide it the same number of times. So now we're just dividing between 0 and 1. And if I deconstruct these domains, all right, it's going to give me basically the end of each one of those domains, and it's going to be the value that we can use to set a diameter to. And in this case, it's nice because now we have an 1/8 inch, 1/4 inch, 3/8, half, 5/8, 3/4, 7/8, 1 inch. These are all very, very common die sizes. Very likely that any kind of high-end fabrication shop will have all of them, and the machine will be able to swap out automatically between them. And all I need to do now is to update my data structure by grafting this, right? And you can see that I have a similar data structure to what we have here. If I hover over 0 through 7, 0 through 7, and I can just go ahead and plug that in there. Now, this is technically working, except that everything is too big, right? So I wanted to show you this because this is real world dimensions. right? Meaning that the way we set these circles is actually relative to kind of real world dimensions for hole sizes, but that only works if we had set our original image, right? Remember our Rhino work. When we set that original image, and we can type in show, when we made this thing, we didn't really care how big it was, right? We just kind of set it into the space. So it scaled too small, right? Now, on your own time, you can go ahead and fix that. You could scale this to an appropriate size and get it so that these kind of 1-inchers and 1/8 inchers actually make sense. But obviously, we're not scaled appropriately, and we're getting all of this overlap. So it's not like the file is wrong. The Grasshopper stuff is doing exactly what it should, but we're giving it an input that's obviously too small to accommodate these kinds of numbers. So let's hide that surface. And instead of using this generic 0 to 1, let's just plug in our minimum values. Remember these that we found from before? Let's just plug those in. But before we do that, we need to first find its overall boundary, like we did up top. So go to Math, Min Max, okay, find its boundary again, and then we can just bypass this domain component here like that. Okay, we can go ahead and delete that. And now we're back on target here. This is going to look exactly or very similar to what it did look like before, but now we've basically organized our circles to actually have some common diameters, even though at this point they're kind of still abstract values, because this is coming from this kind of small surface size that we had set in our Rhino file. So we have a unit problem, but we do have at least an optimization within the boundaries of the units that we're working in and the size of the original base surface, if that makes sense. Those things are very easily matched, right? So all you got to do is just make sure your original surface is actually modeled to the building scale, and this would not be a problem. And because of that, we know we have a good script because it still works. It's actually still robust enough to not break and still kind of follow the logic and give us a pattern that would look very similar even if we did scale it to the size of a building. So it's a good proof of concept. And again, all of this stuff still works, so you could change your pattern as you need to, and the spacing. Okay. All right, so the last step, I think, or one of the last steps, is to just visualize those sets of points, so we can really show where they exist, especially in a drawing set. So where are the smaller ones? Where are the largest ones, and so on? And how does this pattern really work? Instead of this generic kind of red output, we're going to recolor everything with 8 different colors. And instead of, there's a lot of different ways to do this, obviously. You can kind of manually set 8 colors using our kind of custom display, our previewer. You guys probably have a good sense for how to do that. But if not, we'll just kind of do it. So in display, I grabbed this little custom previewer, and then I went over to parameters and grabbed a little color swatch, and I can plug that in and change the color. Of course, I can do this. I can get these separate, each one of these lists out, and I can have eight of these, copy and paste 8 of these in 8 different colors, and set everything manually. I prefer not to do that. I prefer to just kind of develop a kind of a random set of colors and apply it to this one data stream as opposed to breaking it down into several. All right, and I'm going to turn off some stuff, and I'll walk you through how you can develop. This is kind of maybe useful for your other work, but I'll walk you through how to develop a random set of color values, kind of develop them from scratch. So the first thing is, go to Sets, and let's grab a series. All right. Okay, and we know we need 8, because that's how many sets we have, so that's going to be the C input, like so. I'm also going to put a numeric parameter in here. I'm going to set it to 4 for now. This we can change. This one we can't. All right. And you can see now I've got 8 values, but they're separated by a number of, they're separated by 4. So 0, 4, 8, 12, 16, and so on. All right. Now I'll head over to Sets and over in Sequence, grab the random component. This is going to generate a list of random values for us. within a certain color range. So we're gonna first of all run. I'm gonna go to parameters, grab this number 7. It's just the integer component. I'm gonna run the output of this through the integer so that we don't have any kind of decimal place after it. It's kind of helpful. The other thing I'm gonna do is graph this, because again, remember we grafted this information over here. We need to do the same. I need to make sure those are all separate lists. Okay. Okay, the next thing is going to be this n input, and this is the number of random values that we want coming out of this. And we're going to set RGB values, 2 of them being random. So an RGB is basically 3 different numeric channels that create a color. Okay, I'm going to set 2 of them to be random, 1 of them to be 255, so that we can get kind of a bluish to magenta color scheme. All right, I'll show you that in a second. So I'm just going to put in 2 here. So we want 2 random values to come out of this when it's all said and done. But I want the range of those 2 values to be anywhere between 0 and 255. So I'm going to grab another panel and pop that in there. And that's because RGB values are between 0 and 255. Okay, so 255, 255 is white, basically, and 000 is black. Anywhere in between in whatever combination comes out of that is a color. I'm going to grab another integer component and make sure that that's all set. And then I'm going to separate those values. I'm going to go to sets. I'm going to grab one of these, and I'm going to zoom in, hit the little plus sign, and now I've isolated each of those random values. I'm going to move that over. All right. Last thing to do now is to just kind of compile all of this information, and I'll show you what it looks like. All right, so we got a bunch of random values here. Good. Random values here. Good. Okay. The last thing we need to do is kind of put it in a format that fits a color value, and this is going to be looking for well, this can take shaders, it could take kind of RGB kind of, let's say, numeric values, and that's what we're going to give it, and other kinds of things that determine what a color is. And to do that, I'm just going to set it, I'm going to write it, basically, I'm going to write it out parametrically. So I'm going to go to sets, text, and concatenate. And I'm going to zoom in on this, and I'm going to give it 5 inputs. Okay. 3 for RGB values, 2 commas that separate them. Grab a panel from my parameters tab again, and I'm going to type in just a comma. Just a comma, no space, no nothing else, just a comma. All right. And there's my comma, and that's going to go into B, and it's going to go into D. The other thing is, as I mentioned before, I want to set one of my channels, in this case the blue channel, to full stop, so 255. A full range of kind of blue channels relative to the red and greens. It's going to give me a range between, you know, kind of a deep blue to a kind of a bright pink, and all the purples and blues in between. And now what we can do is we can set this in our A and this in our B, and sorry, in our C, and you can see what comes out. So we've compiled, right, RGB values just by kind of taking 2 random numbers and writing it out with a comma in between, and then ending it with the 255. This data looks like it's going to work no problem, and I can go ahead and plug that into our previewer and turn on the previewer. Okay. And you can see that I've got, if I zoom out, I've got a kind of a nice breakdown showing us and revealing to us how our whole pattern now has been reorganized and redrawn with same size diameter circles within these color ranges. And it's a little hard to see, so what I'm going to do, and you can go ahead and do this too if you like, I'm going to go to my little options. I can also type in options in the command line. It's going to pull up our Rhino options. I'm going to turn the grid off first, so turn that off in the grid. And then I'm going to go to appearance, colors. I'm going to change the background to black. Yeah. And I can get a better look at my pattern, because some of those values were kind of light. So yeah, so everything that's in this kind of lighter, this is like a lavender in here, these are the tiny ones. This is the next one up, it's its own color, and so on and so forth. This kind of deeper pink, a lighter pink, and then it gets into the blues. And this, again, this is randomly chosen, so if I go back and, gotta stop doing that. Yeah. If I go back over here and change change this number, which is going to end up being a kind of a seed value, I could get different options to come out of this. as randomly picked by the random component. All right, that'll be one way to do it. Another way to make subtle changes to this, I guess, is to maybe change this value, but this is going to kind of limit your color range to mostly blues. I guess maybe not, actually. That's kind of weird. I guess I get kind of a little bit more greens out of that and so on, so that's kind of cool. Anyway, you get the idea. You can make subtle changes to this as you go, but this is kind of set to kind of within this kind of color range. You could also make that random, so if you were to put another output onto this, change this value to 3, and then replace that, you now end up with a fully random set of numbers without being within the range of pinks to blues. Now we get much more of a variety as I change my seed value. Okay, and that's not looking good with a black background like our other one did. And so I'm just going to kind of swap that out and put that back. All right. Okay, cool. So we've, again, yeah, so now at least you have a representation for, so this could be a good drawing, and you can color code this and determine for your audience which of these circles are exactly what diameters, and we can have a conversation over how this would be fabricated. Okay. If you wanted to, one last thing that I will show is, and I guess I'm going to go back and change my background color once again to white or to gray, and I guess I'll just hit restore defaults. Yeah. And now if you wanted to just isolate out of this list, of points, one of those sets independent from all the rest, we can also do that. So we can show that as well. And I'm gonna use our circle for that. And I'm going to run the same call operation as I did with the points. So I'm going to grab this call pattern. Sorry, no, I don't need the call pattern. You can delete that. Instead, all I need to do is actually just select one of these paths, right? So these are all separated on different paths, 0 through 7. All I need to do is just separate those. And I'm going to use the concatenate again, but first I'm just going to get the right component so I can isolate. So, before we were taking these things, right, the list length, we were grabbing certain items, right? We can do the same thing with trees. We just need to separate the paths. So we can go down to tree branch at the bottom here, all right? And I can plug in this data set into the tree input. Okay, and now the path, I have to give it in the same format. So if I hover over this once again, you can see that I got curly bracket 0, 0, 0, 0, curly bracket. It has to be exactly that or it won't select it. So it's easier to just simplify this. So I'm going to right click, hit simplify, and now you can see that I've got curly bracket, one number, and the curly bracket, right? So all I got to do is plug in one value in order to select the right one, which is much easier. But to do that, I still need to do a little bit of concatenating, right? I need to give it the right data format. I can't just put a number in there; it won't understand it. So first of all, I'm going to grab a slider between 0 and 7, right? And I'll show you that. This will go. Oh, look at that. It does work. Ah, okay. That might be new. All right. Well, older versions of GH, I think, would not allow that, as a matter of fact. So I'm going to turn off that preview. And it looks like because I've simplified it, I actually don't need to do this concatenation, so that's cool. And now I'm able to kind of just select through and select, right, just the smallest to the next one up and so on, all the way to the biggest. So I'm able to actually visualize those separate colors without them being colors. But of course you could do that just by giving this a custom color if you like. But this could make for a nice set of drawings. It could also help you, again, separate out fabrication sheets and so on. So a little bit of analysis to a pretty complex pattern. We talked about ways of optimizing it into particular diameter sizes. and how that's relative, again, to the overall model size, and that's important. So up until this tutorial, what we've been doing is kind of just modeling without scale or without without overall dimension in mind. And in a project like this, you would really need to do that. So on your own time, see if you can experiment with getting this panel to be, let's say, dimensioned appropriately so that you could actually set particular domains into your circle radii. So it means that these 8 here would be actual, let's say, diameters that could be used from a turret punch. So 1/8 inch, right, 1/4 inch, 3/8, and so on. And I walked you through how to do that earlier on. It's quite simple. And in this case, we just kind of changed the game a little bit and made it parametric and more related to the kind of values coming out of the image mapper. Okay, that's it for this one. Image mapper, image background turned into a hole pattern and optimized for and reorganized for fabrication conversation. All right, thanks.